So what is left for us? This particular V is electrostatics of conductors. So this electrostatics of conductors, whatever it is, in the learning process of this is done in three different stages: studying what is happening, and determination of fields, determination of potentials, etc. for conductors. To start with, we will do with the basic case. Charge distribution in case of conducting large plates. They are very large in dimensions, such that the distance of separation is literally negligible. Distance of separation is literally negligible. So the first case I'll take up. So imagine that you just have only two plates like this. Remember, the distance is pretty small. Technically, very small when compared to the dimensions of the plate. Now on this, I have given some plus Q charge. On this, I have given some plus 2Q charge. So how to handle this? The easiest way is you imagine that the entire thing is one single plate. If you can imagine that the entire thing is one single plate, what is going to be the charge on this plate? 3Q. If you are having one single plate, with 3Q charge, how it gets distributed? 3Q by 2, 3Q by 2, provided this is isolated conditions. Remember, they are isolated. Both the plates are isolated. Isolated means there is no other distribution, there is no other conductor, or not even earth connection around. So in this case, what is happening? Same situation you should notice here. 3Q by 2, 3Q by 2. But charge is conserved on each plate because each plate itself is isolated. So to conserve charge, what is the condition required here? You should have minus Q by 2 charge here and plus Q by 2 charge here. What is the total charge on the right hand side plate now on the basis of the new distribution? What is the charge on the left hand plate on the basis of the new distribution? I hope you got my point. So this is how you will have. Of course, the electric field lines will be like this. The electric field lines will be like this. Almost uniform within the plates. Ignore the factors at the edge. Now you take 0.1 here, 0.2 here, 0.3 here. You know, at 1, what is the field? For this purpose, you will take a very small Gaussian cylinder. Like this. At this situation, field is entering at that point. Right? Yes or no? So therefore, minus EDS is the flux. Why I have written minus EDS? Inward flux is negative. This is equal to 1 by epsilon naught time. Can you please tell me what is the charge enclosed by this Gaussian cylinder? Can you see Gaussian cylinder first of all? The Gaussian cylinder is nothing but the one there, this one. This is the Gaussian cylinder. What is the charge enclosed? Sigma in this case is minus q by 2 epsilon minus q by 2 a into ds, because the portion which you have taken is ds. So finally E is q by 2 epsilon naught a. Any doubt in this? Remember, this is E1. Any doubt in this? Any doubt in this part till now? Anna, you have a doubt on that? Sure? Right. Clear. Okay, next. I want a field to find at 2. Simple. Now I'll take my Gaussian cylinder like this. What nature of flux is this, outward or inward at 2? At 2, what is the nature of the flux? Outward or inward? Outward. EDS is equal to 1 by epsilon naught time. Can someone please help me in writing the charge enclosed by this Gaussian cylinder? 3q by 2 epsilon naught a times ds. So finally, epsilon naught enduku? Right. Absolutely correct. Why we require epsilon naught here? We require only 2. Right. So yeah. Ever చెప్పారు? No. On Gaussian surface, whenever I am writing E, it is due to what? All the charge distributions. That's all. I am finding the net field at 1, net field at 2, net field at 3. That's all. But your Gaussian cylinder still encloses only charge on that part. Because anything inside the plate, there is no charge in that cell and no plug at that point. So therefore, E2 is nothing but 3q by 2a. Epsilon naught 3q by 2 epsilon naught a. Trust me, even at 3 also you will have the same distribution. So similarly, E3 is also equal to 3q by 2 epsilon naught a. That's all. Now please go through once again, just please go through the entire setup of discussion. Yes. Excellent. Fox inwards, because at this point E. Okay. 2 దగ్గర ఫీల్డ్ లైన్స్ ఎట్లా ఉంటాయి? 1 కి ఇన్వర్డ్స్, 2 కి అవుట్వర్డ్స్ కదా. నువ్వు క్లియర్ గా సిలిండర్ లోకి ఎంటర్ అవుతుంది. అయిపోయిందా? సెకండ్ పార్ట్ ఆఫ్ ద సిలిండర్ నో ఫ్లక్స్, బికాస్ ఇట్ ఈస్ ఇన్సైడ్ ది plate. See, there are two different cylinders. Notice that. Any doubt? This is the basic. Remember, when is this correct? Plates must be conducting, plates must be large in size, and plates must be identical. And one more important point, the distance between the plates is very small when compared to the actual dimensions of the plate. Any doubts? So here, plates are very large. Distance between them is negligible when compared to size of the plate. Therefore, E will be uniform. Except at edges of plate. Begin according to the ration. You should not struggle. Why I am writing it like this? Right out till this point. That's a very fundamental case that I have discussed actually. A very fundamental case. I'm recording this class. I still believe that some of these students have some XYZ reasons. So that I don't want them to miss this class. I'll post the recording of this class immediately after that. But those who have arrived today, you must be justified. But that's what happened. Right. The next part of the class is like this. Now you are given good. This is the next case 2. Okay. Na? So the charges that I have given is plus Q, plus 2Q, minus Q. Now how the distribution gets affected? For this purpose, to avoid confusion, I will name the phases like this. Phase 1, phase 2, phase 3, phase 4, phase 5, phase 6. Just for identity. Like how the way you are getting roll numbers. What if I take this as a single plate with just 1 and 6 open? What is the net charge on this system? How much? So how will get distributed? Q and K. First write Q here, next write Q here. But each plate is itself isolated. So each plate charge must be conserved. Remember, when I will dare to conserve the charge on each plate, so long the plate is isolated. Now this is 0. Zero, obviously, 2Q minus 2Q. Please notice that whatever the flux of 2Q is ending at, whatever the flux that starts at 4 must end at 5. That is the reason why when on the phase 2 the charge is 0, obviously on the phase 3 charge must be 0. In fact, there is no electric field in this zone between 2 and 3. Then the electric field, how to find? Now you know how better idea how to find fields and all that, very clear cut idea. Now please confirm, have you understood the way that I have? See, in this process, irrespective of the distance between the plates, the distribution remains the same so long each plate is isolated. Any doubts? Now a change. Now what I am going to do is, there is a provision to connect it to A. Initially, the charge given to A is plus 2q plus q minus 4q with key open minus 4q. Q minus 4q. Any doubt? Now I am closing the key. Now, when you close the key, what happens? When you close the key, what happens? Now, do not write the charges like this. Wow. Now, when I close this, tell me what to do. Now, this is on A, on B, on C. Now I have closed it. They are the same logic. It's like one single plate. The net charge is which means the charge here is 0 and the charge here is also 0. But still plate A is isolated. So let me see how to conserve the charge. Very simple. You will have plus 2q charge here. And you will have minus 2q charge here. And don't conserve here. Do not conserve charge on C. Why? Because it is earthed, so it is not isolated. But B is still isolated. So what should be the charge on B now? The right side face of B. So to conserve the flux, minus 3. Earlier, the charge on initially charge on plate C is equal to minus 4q with key open. Finally, charge on plate C is minus 3q with the key closed. Can you please help me what is happening over here? So from earth to plate, a charge plus q transferred. Earlier you are having minus 4q. Added plus q. What happens to you now? Minus 3q. Okay, I can answer it in a different way also. What is the total charge of your system? Before key opening here. Before minus key opening. Minus q. To make the total charge 0, what is required? Plus q. So that has flown from earth to the system. That has flown from earth to that system. So that made the entire charge distribution 0. Any doubts? ఎర్త్ కనెక్ట్ చేస్తే పొటెన్షియల్ 0 అవుతుంది, ఛార్జ్ 0 అవుతుంది యాక్చువల్గా. బట్ ఇవి ఐసోలేటెడ్ ప్లేట్స్ కాబట్టి 0 అయింది. ఎందుకు ఎర్త్ కనెక్ట్ చేస్తే పొటెన్షియల్ 0 అవుతుంది? ఎర్త్ పొటెన్షియల్ ఇస్ 0. We refer, it's a reference only. Actually, earth potential is not 0. If you take a solar system as 1 unit, earth as an isolated conducting sphere, I heard that the potential is of the order of minus 100 to minus 400 volt, somewhere. But whatever it is, the reference what we are taking is earth as 0 volt. Okay? Right. Any doubts? Boys? Any doubts? Next. So someone was keenly observing why you mentioned a distance and did not use it at all totally. Now I'll take oh no. No. From earth to plate. If it is a plate to earth, minus q transfer. If that is the case, minus q is transferred from plate to earth. But the general traditional way of expressing the same is plus q transferred from earth to plate. Honestly speaking, I should say minus q is transferred from plate to earth. That is the actual mechanism. Same arrangement. Good. Now, with the key open, A is having a plus q, B is having plus 2q, C is having minus q. That's how charges are there. So, what happens when key is closed? Remember, there is no earth connection here. there is no earth connection here, which means still the total charge of the system is minus q. So obviously minus q by 2 minus q by 2. Hold on. Don't dare to conserve the charge on plate A. Why? Plate A is no longer isolated. So you will have some q and charge over here. And equivalent minus q and charge over here. But you can still conserve charge on plate B because B is still isolated. B is 2q actually. So practically this will be 2q plus q1. So an equivalent minus charge. Okay. Got the point? Right. Now what is happening over here? Now see, charge redistributed, that's fine. But how to find Q1? The potential difference of A and C is 0. Why? See. Why VA minus VC is 0? Tasya. Rutvik. Yakada, there is no earthing here. There is no earthing here. Nowhere. Same charge. From A to C. Sir, as they are attached, that will be uniform throughout. As they are connected by a conductor, the potential of A and potential of C will be same. That is how to answer that. Why I stopped here? Why I am questioning you? You need to know, since A comma C are connected by a conducting wire. Okay. In this region, let the electric field be even. In this region, let the electric field be U2 and they are uniform actually. Can someone please help me in writing even? Q1 by Q1 by Q1 by epsilon naught A. Tell me how. How? This is the nature of the mistake you normally do. That is the nature of the mistake what you normally do. That's now we have done. Right. Yeah, tell me what is E2? E2 is 2Q plus Q1 by epsilon naught A. Why minus? Right. Right. Now, The actual question starts. VA minus VC can be written as VA minus VB is E1D plus E2 times 2D is equal to 0. Q1D plus 2Q plus Q1 times 2 is 0. I am just here. Don't question me about the all chiller and all that. So therefore, Q1 plus 4Q plus 2Q1 is equal to 0, which implies Q1 is nothing but minus 4 by 3Q. Wow. Now I have a question. Initially, charge on the plate A. No confusion again. What is the initial charge on plate A? Anyone? Plus Q. Final is equal to minus Q by 2 plus. Yeah, can you please help me in writing this? 11Q by. What is the difference? Minus 11Q by 6 minus Q. Minus 17Q by 6. Any doubt till this point? Now, what is happening over here? So, through key, delta Q charge transferred. Any doubts? Any doubts, boys and girls? Do you have any doubts? So this is the concept of electrostatics of parallel plates. Basic concept. I'm still discussing basics. Similarly, we will discuss concentric shells now. Okay? We will discuss now concentric shells. Simple cases only, again. So complex cases we will discuss later. Simple cases I am discussing purely the fundamental way of solving these models. I'm just introducing things. Right. Right. So now we are proceeding further, and in the process, we will take up concentric cells. Let us try to discuss what happens in case of a concentric cells. So I am again telling you this is not the complete information. I'm just adding. I'm just giving you the basic approach of handling these things. Please try to understand basics. See, if we have a shell like this and you have given a charge, the charge distribution happens uniformly. If this is of radius r, the potential on the shell is 1 by 4 pi epsilon naught q by r. This can be written as sigma r by epsilon naught, where sigma is charge density. So if it is any surface, any shape, usually we will take sigma into r as a constant. For example, if the shape is something like this, now let us take 2 points, point 1 and point 2. The entire thing is an equipotential surface. See, try to please understand the radius of curvature at 2 is greater than the radius of curvature at 1. Agree? Therefore, sigma 2 will be less than sigma 1. Why? To maintain the potential constant, the distribution gets adjusted. But to maintain constant potential, sigma adjusted according to R. In the same, there is a special case. If we have a sharp edge like this here, you take point 2 and point 1 here. At 1, R tends to 0. Sigma very high. At these points, you know what happens? Charge will discharge into space. Such a discharge is called corona discharge. కరోనా డిశ్చార్జ్ అంటారు. ఆ షార్ప్ ఎడ్జ్ అయిపోయింది, చార్జ్ లీక్ అయిపోతుంది, ఇట్స్ లీక్ ఇన్ టు ద స్పేస్. We will use the same principle to arrest lightning around us. That is the reason why on the tops of the buildings, we will place an arrangement like this. It's connected to ground. Some aerial like kind of, you can see that one Trishul type of arrangement, not that Lord Shiva will bless that building. Okay. So on if you see Sri Sailam temple and all that, on the top of the Gopuram, you will see Trishulam, both the faces. If you see Chakram, that is Lord Vishnu's temple. From very far distance, you can identify. If it is a Trishul, it is Lord Shiva's temple. Likewise. Okay. So therefore, that is not the purpose. This is called lightning conductor. This is called lightning conductor. So what is the objective of this? If there is a sudden thunderstorm in your place, sudden discharge, lightning means sudden discharge of charge. Huge amount of charge, few very high volts of charge will be discharged. But if it discharges through a building, entire building gets electrocuted. You know, lot of times you will see when there is a thunder, you will be hearing other day news, a lot of TVs, refrigerators, ACs, particularly what will spoil first is a Wi-Fi router. Because it will have a natural antenna. You will see that they will burn simply. But that is how strong the lightning is. So therefore, almost on the top of every building, such an arrangement is provided, lightning conductor. What will happen when such a charge appears close to the building? How the way you said the discharge takes place to sharp edge, catching is also possible through the sharp edge. The sharp edge will catch that particular charge and discharges to the earth through some conducting wire like this. And this will avoid passing of charge through the building. And we are protected because of this. Right? So I've just introduced the basics related to this. Now we will go one by one after the other. Even if you have a conductor like this, okay, and you have some cavity type of arrangement like this, electric field is zero in this, even though you have charge outside. Inside the cavity, electric field is zero. And this is the principle called electrostatic shielding. Electrostatics shielding. To protect us from external fields, this cavity behaves like a shield for us. Okay? Right. That is the reason why when there is a thundering outside, stay in your car. Your car protects you. Your car acts like this thing. But remember, I am assuming all that indoor interior stuff is insulating material. If you hold your hand on what you call the outside part of the car, you will get electrocuted. During thundering storm, it is better to stay inside the car. By the principle of electrostatic shielding, you'll be protected from that huge charge passing through you. Any doubt till this point? I've just done basic. Now, for example, you have concentric shells like this. One is a shell of a radius A. The other is a shell of radius b. Remember, inside can be sphere also, no issues, but outside is a shell. This is a thin shell, thin conducting shell. Now you have a charge Q1 over here and a charge Q2 over here. What is the potential at a point inside on the inner sphere? Simple. Due to this charge distribution, due to outer charge distribution, V out any doubt? Sorry, you are cheating. No, I'm not cheating you. No, sir, you have written both the terms same. True, because with respect to this distribution, whatever is the potential on the surface, same will be at any point inside. You know that. Inside a charged cell, potential is constant. So only due to this distribution on the surface as well as any point inside, potential is the same. That is the reason why you got both the terms the same. But whereas in this case, it is a point on the surface and it is a point on the outside side. Now, what is potential difference? V in minus V out. This is simply KQ1 times 1 by A minus 1 by B. Remember, this potential difference is independent of charge on the outer shell. Depends only on inner shell. But in this arrangement, what is the charge distribution? Now you have plus Q here, but plus Q1 here, minus a Q1 here. What is the charge on the outside? Q1 plus Q2. Therefore, a point P strictly outside, which is at a distance R from the center. What is the potential at this point? Shell theorem. At the center of the shell, what is the total charge now? Q1 plus Q2. So 1 by 4 pi epsilon naught Q1 plus Q2 by R. That's the. Any doubt, boys and girls? This is a very fundamental approach that what I have given to you now. Any doubt in this, boys? You have any doubt in this? Now I am doing the same thing, but the question is same thing, but the question is right, same situation. A, B, connected to Earth. Simply what happens is the charge Q1 and minus Q1 is the picture. There is no charge outside. So what is the expression for potential difference? Simple. 1 by 4 pi epsilon naught times Q1 times 1 by A minus 1 by B. That's the potential difference. Are we clear? Next. At any point here, P. Q1 by R. Now what about a point P dash? Which is at a distance R dash. Another Ostad. V at P dash is Y0. As per Shell theorem, the net charge at the center is 0. Got the point? Any doubts? Yes. What is the charge enclosed by this outside sphere? 0. Net charge enclosed by this system. Inside Q1, outside minus Q1, net 0. I am not speaking about VP, no issues. VP, apply Shell theorem. When you are taking only P, your Gaussian surface is this. So that part is enclosing charge Q1 only. Minus Q1 की local plus Q1 की మైదా 2K నువ్వు అడిగేది ఏంటంటే నువ్వు ఆ కాన్సెప్ట్ వేస్తానంటావు అంతేనా? No issues. ఏమంటావు అంటే ఇది కదా వేయాల్సింది. That is potential difference. You are asking only potential. We are comparing potential difference at this point versus some other point. Yes, what you said is right. At that point, potential is strictly this term only. Now, why minus Q naught by R term gets affected? Tell me. 1 minute. Let me just check. Am I doing any mistake? 1 minute. 1 minute. 1 minute. There is no confusion here. What is the intensity of the electric field at a point inside? 1 by 4 pi epsilon naught Q1 by R square. Agreed? Now with this minus EDR 1 by 4 pi epsilon naught Q1 by R square dr. A to some R. So what will happen? 1 by 4 pi epsilon naught Q1 times 1 by A minus 1 by R. Yes. That is the potential difference between yes. Yes or no? That is potential difference. కదా విపి మైనస్ విఎస్ఏ కదా ఇది. ఒక్కసారి కరెక్ట్ చేశానా లేదా నాకు ఒక్కసారి చెప్పండి. Yes, Vs minus Vp. Correct. Good. So Vs, what is the Vs minus Vp? It's not V. Vs ante 1 by 4 pi epsilon naught Q1 by A. minus V at P is 1 by 4 pi epsilon naught Q1 by A so therefore potential at point P is 1 by 4 pi epsilon naught Q1 by R. Any doubts? Sure. Don't get confused between potential and potential difference. Right. Now I'll take a twist here. What if now try to please understand when you have a charge Q here, what is going to be the charge over here? Let it be Q. Remember, for whatever may be the condition, the potential at this point must be 0. Why? It is connected to Earth. Remember, connected to Earth implies potential is 0. But not charge is equal to 0. Lot of people have this confusion in mind. Connecting it to Earth means potential as well as charge 0. If it is an isolated plate, it has some charge. You connect it to Earth, the entire charge is lost undoubtedly, and the potential is 0. But in this case, it is not that situation. And not only that, in this case, KQ by A plus KQ by B is the potential at the point inside 0. So therefore, Q will take the form minus A by B. Now you choose some point P dash over here, which is at a distance R. So now what is the potential at that point? Potential at that point P is 1 by 4 pi epsilon naught Q by R, 1 by 4 pi epsilon naught Q by R. So therefore, 1 by 4 pi epsilon naught R into Q plus Q. Can you please help me? What is the Q plus Q? So this will become B minus A by B times Q by 4 pi epsilon naught. So I have just given you some elementary discussion of concentric shunt. ఎక్కడెక్కడ ఒకసారి క్వశ్చన్ అడిగి జాగ్రత్తగా. నేనేం అనలేదు అట్లా. పొటెన్షియల్ 0, పొటెన్షియల్ డిఫరెన్స్ 0 అని ఎక్కడన్నా? దీనిలోనా? Potential of A, potential of C 0. So potential difference 0. But that case, this case is different. The potential of this is a different thing, and the potential of this pair is a different thing. The potential difference is not 0. What do you mean by net? That's what I have written here. Potential at this point is 0. The potential at this point is not 0. If you question me about the potential at this point, say some point 2. Let this be V1. V2 is nothing but 1 by 4 pi epsilon naught Q by B plus Q by P. Right. The same situation you will face. B minus A into Q by 4 pi epsilon naught B square. Any doubt? Pakka? Okay. I'll just stop my discussion.